Today we're going to be covering 10-6 similar triangles. Our main idea today is to determine if two triangles are similar, and then our second main idea or objective is to use proportions to find unknown lengths of similar triangles. Okay? Much of this comes from 6th grade, so you may see some things that are familiar to you. Okay? And looking forward, you will be seeing this in geometry as well. Algebra standards would be a standard 2 and also standard 1 because we are going to be using proportions and properties to calculate. Okay, the first thing is vocabulary. Similar figures. Now, similar figures can also include similar triangles. So figures that have the same shape and corresponding angles are congruent and corresponding side lengths are proportional. So many of you are probably wondering what corresponding means. Corresponding means that they are matching, okay? And congruent means that they are equal. You'll also notice that there's a symbol for similar. We use this symbol, also known as a tilde, this symbol to represent similar. So you'll be seeing that frequently throughout the lesson today. Okay? So moving on with that, let's show you a visual on this. What does this look like? Okay? So in this diagram, I have a statement that says triangle ABC is similar to triangle XYZ. Okay, that's what this little mark says. That's what the triangles are for. So what that really means is that angle A matches to angle X. And you'll notice that they're in the same location. They're both first here. So A matches to X. B matches to Y. So I could say B, I'm going to put a double mark on B, matches to Y. Okay? And then C matches to Z. I'm going to put a triple mark to show C matches to Z. Now, the reason why we put different markings also is to show that they are different from each other. So that means B is not the same as A, B is not the same as C. Okay? So you can see that they're all different angles. Okay? But they are the same as the corresponding one on the other triangle, so the matching one. Okay? So let's do a little bit of matching to get warmed up here to similar triangles. Okay? Which angles correspond to each other? In other words, which ones match in my diagram now? You notice angle A matches with angle X, so I'm going to write angle. By the way, this marking is what I use for angle. Okay, it looks like a less than sign, but we're going to put a little angle mark in it. So that stands for angle. Okay? Angle A is, and this is another notation, congruent, which means they're equal. We use a congruent sign. Angle A is congruent to angle X. Angle B is congruent to which other angle? Notice two marks, angle Y. Angle C is the same as angle Z. So you'll notice these are the three pairs of matching angles or corresponding angles. Okay? Now the next thing in that definition of similar figures, the corresponding side lengths have to be proportional, which means that matching sides have to form a proportion. So let's take a look. Which sides match? And you can also use the angle marks to help you with that. Okay? So from 1 mark to 2 marks, we have A to B. So A to B matches to 1 to 2 marks, X to Y. And this is proportional, which means that the ratio is equal to 2 to 3 marks, B to C in the same triangle. We're starting with the same triangle. Y to Z. And then finally, we're going all the way around, 3 to 1 mark, C to A. And C to A would match with Z to X. And now we formed a proportion. Now you'll notice that this has 3 ratios. Okay, so this is what we call a proportionality statement. And what that means is it just says which ones will be proportional. So I can cover up any one at any time and actually form a proportion. I could do these first 2 and cross multiply to solve. I could do the last 2, or even the first and the last and cover up that middle one. Okay? So I can choose any two of them to form a proportion. Okay? All right, so we're going to go ahead and do our first example. Example number 1. We're going to determine whether ABC, triangle ABC, is similar to triangle DEF. Now keep in mind that based on that definition of similar figures, that means two things must be satisfied. Okay, there's two conditions. Number 1, are the angles congruent? That's the first condition we have to satisfy. Secondly, second condition, are the sides, the corresponding sides, proportional? Okay, that's our second condition. Okay, so let's check. Are the angles congruent? Well, A has 1 mark and it matches with D, which means A is congruent to D. These are called congruency marks, so it shows that this is the same as this. So check. Angle A is congruent to angle D. Okay, we notice B has 2 marks, E has 2 marks. So angle B is congruent to angle E. Check. Finally, C has 3 marks and F has 3 marks. So I know that angle C is congruent to angle F. And you'll notice that when I'm doing this, I'm always starting with the same triangle. Okay, so that way I don't mix anything up. Always start with the same triangle each time. Okay, and then lastly, the corresponding sides. Are the sides proportional? So let's check. 1 to 2 marks, that would be 4. To 1 to 2 marks, that's 12. Will that ratio equal 2 to 3 marks, which is 6? Then E to F, 2 to 3 marks is 18. Will that ratio equal C to A, which is 5 marks, to 3 to 1 mark here, 15? So let's check. Will this work? Well, 4 to 12, I can reduce that. When I reduce it, it becomes 1/3. When I reduce this one, it becomes 1/3. Reduce this one's 1/3. So don't they all reduce down to the same fraction or same ratio? Yes, which means yes, these are all proportional. Okay? So to answer this question, because it does say justify your answer, I need to make sure that I answer the question. So yes, these are similar triangles. These are similar, I'm going to use a little notation, triangles. Okay? Because the corresponding angles are, I'm going to use a symbol again, congruent, and the corresponding sides are proportional. So that would be my formal answer for this question. Okay? So moving on, another example. Okay, example number 2. Determine whether the pair of triangles is similar. Very much like our example number 1, but you'll notice this is a little different. Notice they give us actual angle measures. So one thing we need to go back to is how many degrees are in a triangle? Do you recall that? Remember that a triangle has 180 degrees, okay? Which means all 3 of its angle measures, when you add up the angles inside, it should come out to 180 degrees, okay? So why is that information going to help us on this question? Well, if you take a look, I've got, this is 42 degrees and this is 42 degrees, which means inside this triangle, these 2 angles are congruent, okay? So they are the same. Well, if these add up, when I add these up, 42 plus 42 will give me 84 degrees. That's just these 2 angles. So how much is this angle here then, angle Q? I need to find out how much that is. In order to do that, I know in a triangle I have 180 degrees, so I'm going to subtract off what I just found. So 180 degrees minus 84 degrees will give me 96 degrees, which means angle Q is 96 degrees. So now I need to check the other triangle. Well, it says that T is 96 degrees, and then they say these 2 angles are the same. They're congruent. So what that means is I have 180 degrees total. I take off 96 degrees for angle T. What will that leave me? That'll give me 70, 80, 84 degrees, right? 84 degrees is left for two angles. So if I take the 84 degrees and split it for two angles, what is 84 degrees divided by 2? That'll give me 42, which means this must be 42 degrees and this is 42 degrees. So now that I've filled in all my degree measures for all of my angles, now I can figure out whether or not these are similar. Are they similar? Are all the matching angles equal to each other? In other words, is P equal to S? We got 42 and 42. Check, check. Q is 96, T is 96. Check, check. R is 42 and U is 42. Check, check. So now I can make a statement. Triangle, I'm going to start in this corner, PQR is similar to triangle, make sure they match. P matched to S, S, Q matched to T, T, R matched to U, U. So triangle PQR is similar to triangle STU. How do we know that? We know this is because corresponding angles are congruent or equal in measure. Okay? Okay, so your turn this time. I want you to go ahead and try problem number 1. Okay, try problem number 1 is on page 563, problem number 2. Okay, good, give that a try. So moving on, our next example, example number 3. Now that we know about the angle measures, and we know that in order to have similar triangles, we also need to have sides proportional. So let's take a look at this next example. We need to find the missing measures for this. Okay, example 3. So what they're giving us is this. Triangle RST is already similar to triangle UVW. What that means is the angles already match. So I'm going to go through and just match my angles. R matches to U, S matches to V, and T matches to W. Notice I'm putting the different marks again like I did earlier. Okay? Now I'm going to go ahead and match the sides. Here's our little note. Match the side lengths. Then after that we're going to set up proportions and then solve it. So let's match our side lengths. So R, 1 mark to 2 marks is 15. S to T, 2 marks to 3 marks is 5. Okay? And then 3 to 1 mark is X. So this was all from one same triangle. They all go on the top. Now I'm going to go ahead and match them to the bottom ones. So 1 to 2 was the 15. Where's 1 to 2 on my second triangle? It's 6. 2 to 3 was the 5. So 2 to 3 on this other triangle is the Y. 3 to 1 was the X. 3 to 1 is the 5. Now this statement of proportionality that I have right now will help me set up my two proportions to solve. So what we're going to do is we're going to create two problems, one to solve for X and one to solve for Y. So to solve for X, I need to have X. So I'm going to take the ratio with X, X over 5, X to 5. And then what I need to do is pick another ratio in here that has enough information so I can solve. The one with the most information is 15 over 6. So using this, I can cross multiply using my cross product property and solve. So cross multiply, I get 6 times X equals 15 times 5. Okay, I'm going to go ahead and use a little shortcut here instead of multiplying that out. I'm going to go ahead and divide by 6. So I get X equals, and I'm going to go ahead and factor and reduce. I know that 15 is 3 times 5. And I know that 6 is 2 times 3. So can I reduce any of these factors? So I'm replacing this. So I notice that I can cancel out the 3's. Okay? And then leaves nothing else to cancel. So then I'm going to simplify. I have 25 over 2. You can actually leave the answer as 25 halves. Or if you want to, you could say you've got 12 and a half as your length, 12 and a half units. So either one of those is fine. Okay, improper fraction is probably most preferred. So now it's time for the y. So I'm going to pick out the y, which is 5 over y, equals, which one has the most information? 15 over 6. and I'm going to do the same. So I get 5 times 6 equals 15 times y, divided by 15. 15 is 5 times 3, 3 times 5, 3 times 2. So I'm going to go ahead and cancel. I've got my 5 and my 5 I can cancel, 3 3, so I'm left with 2. So y must be 2 units, right? So now it's your turn to try a problem. Okay, this is our try problem number 2, which is on page 563, problem number 16. Go ahead and give that one a try. And then finally, give that one a try. Finally, our last 2 examples here. Example number 4. Name the similar triangles and find the missing measure. Now this one's a little tricky because if you take a look, you see this big triangle, but what you don't see is there's a smaller triangle hidden inside. I'm going to go ahead and just outline that so you can see it. This small triangle inside. So the best way to do this is to probably separate the triangles. So I'm going to separate. I know I have a big triangle, which is A, E, and C. And then I have a smaller triangle, which is B, D, and C. Now I'm going to label it. I notice my small triangle has a bottom leg of 3 centimeters, and then it has a hypotenuse of 4 centimeters. These are right triangles. My larger triangle has a leg length of A centimeters and a hypotenuse of 10 centimeters. So I'm separating it so it's easier to match. So the question asks 2 things. Number 1, name the similar triangles. So which triangles are similar here? We've got triangle A, E, C is similar to which other triangle? B, and we have to match it. E is right here, it has a right angle, so it has to match D and then C. So that's the first part of the question. Second part, we have to find our missing measure. So this is where we do our matching and solving. So let's go ahead and match that and then solve it. So looking at this smaller diagram, which sides match? I've got 10 centimeters matches to the 4 centimeters, and I've got A centimeters matches to the 3 centimeters. I can do my cross multiplying, so 10 times 3 equals 4 times A. Go ahead and divide by 4. So A equals, and reduce by 2 here. So I get 15 over 2, or if you would like, you can also say 7.5 centimeters. Okay? That's it. And finally, our last example. What if they don't give you a diagram at all? Suppose a lamp post is 20 feet high and casts a shadow 30 feet. Pole located right next to it casts a shadow of 12 feet. How tall is this pole? Well, draw a diagram. Draw your lamp post. Okay. And then have a shadow and label it. Our lamp post is 20 feet and the shadow is 30 feet. Now next to it there is another pole, using another color here. Suppose next to it there's a smaller pole, and this smaller pole casts a shadow of 12 feet. But we don't know the height of this pole, so I'm going to call it P for pole. So what I'm going to do is create similar triangles. You'll notice these are 2 legs, so this is a triangle. And then you'll notice the larger one, this is one leg, this is the other, and this is my other triangle. So which sides match on here? 20 is the height of this pole, height of this pole. So 20 to P equals, I started with my large lamp post, so I need to go to its shadow. Its shadow is 30 feet, and the shadow of the smaller pole is 12. And same thing, cross multiply and solve. So I get 20 times 12 equals 30 times P. Divide by my 30. Quick math here. 3 goes in here 4 times, and that's 8. So my pole must be 8 feet. So now it's your turn. Last try problem. go ahead and try. This is the third problem, and this problem is located on the next page, which is on 564, number 26. Okay, and bring that problem to class tomorrow with the other two. See you in class.